Okay, so here we have ocean waves traveling at 4.5 meters per second. So in the deep water, their initial speed is 4.5 meters per second. And when they pass into shallow water, the speed slows down to 2.0 meters per second. Now the angle of incidence for the waves traveling into the shallow water happens to be 65 degrees to the normal. So what does that look like? Well, if I finish my sketch here, the incident waves in deep water traveling in this direction, when they hit the boundary, the normal line is always 90 degrees to the boundary. So you've got to imagine this normal line something like that, so that's 90. They're saying this angle right here, which I'm calling the angle of incidence, is 65 degrees. Now the angle of refraction should be a little bit smaller. When waves slow down, they bend in towards the normal line. So we'll see if that's true. Now in this question, we have velocities. So in our refraction equation, we have this information and we have angles. So we want to use this version of our refraction equation. Like that. Now we know V1. V1 is 4.5 meters per second. We know V2. Our refracted speed is 2.0 meters per second. We know our incident angle, 65 degrees. And we're looking for our refracted angle. So when I write my equation, I want to solve for theta r, so I want to get that on top. So the first thing I'm going to do is multiply both sides by sine theta r. It's all one function. So they're going to cancel on this side. Now I want to get sine theta r by itself, so I'm going to multiply both sides by V2 and divide both sides by V1. And I'm going to end up with sine theta r is V2 sine theta I all over V1. So that's 2.0 times sine of 65 degrees. Make sure your calculator's in degree mode. All over 4.5. And when I want to find the angle, I have to do sine inverse. So let's get a number first. So when I go 2 times sine 65 and divide it by 4.5, I get 0.4028. Leave a few decimal places. So theta r will be sine inverse of that. So second function sine, and I get 23.75. or 23.8 degrees. Remember, that's this little angle with respect to the normal.